So we're told that an open top box is to be constructed so that the base is twice as long as it is wide. Its volume should be 2400 centimeters cubed. Find the dimensions that will minimize the amount of cardboard required. Okay, so all I've done so far is I've drawn a little picture of what our box is going to look like, and I've shaded in the top to indicate that the top is open. What we want to do when we're approaching these optimization questions is first figure out what is the quantity that is going to be optimized. What are we trying to make as big or as small as possible? And so the key here in this question is that we want to minimize the amount of cardboard required. Now, if we're talking about the amount of cardboard required, mathematically we're talking about the surface area. So we are going to need an expression for the surface area of this box, and that's the equation or the formula that we're going to work with when we take the derivative, set it equal to 0, and so on and so on. So we know this is where we're going down the line. But first, let's just take a look at the information that we are given here. So we got the open top box. We've drawn it with the top that's open. Its base is going to be twice as long as it is wide. So let's choose some variables here. We'll say that this is the width, this is the length, and this is the height. And we know that its base is twice as long as it is wide, so our length is 2 times our width. The volume should be 2400 centimeters squared. So that tells us right away that one of the equations we need to work with is going to be our volume equation. So we need an expression for volume. How do you calculate the volume of a rectangular prism or a box here? Well, it's going to be length times width times height. But we can change that a little bit for what we have because we know that our length is 2 times our width. So this is length is 2 times the width times height, or 2w squared times the height. Now we're given that the volume should be 2400 centimeters cubed. So we can set this equal to 2400 2w squared h. Okay, and if we want to simplify this a little bit, we can divide both sides by 2. 1200 is going to be w squared h. Okay, so that's one of the formulas that we're going to be working with. But the main one that we're going to be working with is this surface area formula. It's the one that we want to actually take the derivative of. So looking at our picture here, let's come up with a formula for the surface area of this box that we are going to build. So the surface area is going to be composed of, we've got the base, we've got, let's say, 2 ends, and then we've got the 2 sides. So if we add up the area of all of those parts of our box, that'll give us the total surface area. So our base is, let's see, it's a rectangle. It's going to be our length times width, but our length is 2w and our width is just w, so that's going to be 2w times w. Our 2 ends, there's 2 of them, and each one is width wide. Like when I'm talking about the ends, I'm talking about this one here and the one on the opposite side. So those are each going to be w times h. And then our 2 sides, again, there's going to be 2 of them. And when I'm talking about the sides, I'm talking about over here. So each of those is going to be length times height, but our length is 2w times height. Okay, so now let's simplify this a little bit here. We get 2w squared, 2wh, and then 4wh. And then it looks like here we can collect some like terms to get 2w squared plus 6wh. Now, this is the equation that we want to take the derivative of. The problem is that we have 2 variables in here. We've got width and we've got height. So we want to get this to be a function of a single variable. So what I'm going to do is I'm going to go back to this other equation that we were working with up here, this volume expression, and I'm going to rearrange it to solve for the height. So the height is going to be 1200 divided by w squared. And then I'm going to take this and I'm going to sub it in way down here where I see the h. So this is going to become 2w squared plus 6w, and then 1200 divided by w squared. All right, so now we have a function that only has w's in it. So we can simplify this a little bit. 2w squared is going to stay the same, but the 6 times 1200 is going to be 7,200, and we've got w and then w down on the bottom, so that's going to leave these sort of we can cancel, leaving us with just a 1 down on the bottom. But then I'm going to write it like this, w to the negative 1, because that's going to make it easier to take the derivative. Okay, so now let's go ahead and do our optimization here. We are going to take the derivative of that formula. So first term becomes 4w, we bring down the negative 1, we get negative 7200, w to the negative 2. How are we going to find our maximum? We are going to set this equal to 0, and we are going to solve for w. So let's see, we can have 4w. I'm going to bring the term with the second term over to the right hand side, and as I do that, I'm going to rewrite the w to the negative 2 as a w squared down on the bottom. And now I can cross multiply by that w squared, so that's going to give me 4w cubed equals 7,200. If I divide both sides by 4, I'm going to get that w cubed is 1,800. And so taking the cube root here of 1,800 gives us our value for w. W is going to be 12.16. We'll just keep 2 decimal places here. So that is going to be the width that is going to optimize the surface area, or make the surface area as small as possible. Now let's go back up to the top here and figure out what we need to actually answer this question. They ask us here to find the dimensions. So we've got one of our dimensions. Like when they say find the dimensions, they mean find the length, width, and height in this case. So we've got the width, we need the length and the height. The length is pretty easy because we know that the length is 2 times w. So our length here is just going to be 2 times w, 24.32. And to get our height, we have to go back to this formula here that we had for the height in terms of the width. The height is 1200 divided by w squared. So 1200 divided by, our value for w is 12.16 squared, and we work this out and we get 8.12. So those are our dimensions. So we finish it all off by writing a nice little conclusion here. Therefore, we'll just say the box should be 12.16 centimeters by 24.32 centimeters by 8.12 centimeters. And we're done.